Hi, I'm Ignacio, and this will be my short or 10-minute introduction to sampling. In this short lecture, we'll see what a population is, what is a sample. You've already seen this in your basic stats course, I'm sure. But this short lecture is designed to talk about the concept of a representative sample, what that means, what is a representative sample, and that will require for us to bring the concept of sampling bias, and we will go through several examples so that you can understand what it means to say that you have a representative sample, or what the concept of a representative sample is. So let's get on with it. So let's start with the population, and let's define the population as the aggregation of all elements in which we're interested. Oh, and there. All right, in which we're interested. So the research question defines the population, right? Your population is defined by your research question. Let me give you a couple of examples. So let's say we have a research question that states how many undocumented immigrants in the US have health insurance. In that case, the population, or the aggregation of all elements that we want to study, is composed by all undocumented immigrants in the US. Or if your research question is what is the obesity rate in the US, then your population, or the aggregation of all elements, right, of your study is composed by all the people in the United States, all of them. Having a sort of smaller research question, what percentage of CHHS students live on campus? In that case, we're interested in all CHHS students, right? All students at CSUMB who have a CHHS major. Now, your population doesn't need to be only people. It can be cities, it can be countries, it can be groups, it can be classes, it can be anything really you want, depending on what your unit of analysis is. And again, that will be defined by your research question, right? If your research question involves individuals, then your population is the aggregation of all individuals that you're interested in. If your research question involves families, then your unit of analysis is the family, and your population will be the aggregation of all the families that you're interested in. So, in most studies, we will not be able to observe the population because it's so big, and because we will never be able to observe it in its entirety. So we need to rely on a sample. And it turns out that if we obtain a representative sample of that population, that is a sample that is unbiased, and we'll discuss these concepts in the next slides. If we have this representative sample, we can make predictions about this population, or understand this population fairly accurately without the need to observe it in its entirety. So, and that is the beauty of statistics, right? That we can do that we can explain the population just by selecting a sample from it, a representative sample from it. So a sample is a subset of that population, right? So if the population is the collection of all elements that we're interested in, then a sample is a subset of that, right? So suppose that the population is all CHHS students at CSUMB that are declared as a CHHS major. That's 250 of them. If we select a subset of that, 25 students, then we have a sample of CHHS students. Now, sampling is the process of obtaining a sample from the population. The process of obtaining a sample. How did you select these 25 students? Right? You had to use some process, and that process is sampling, right? what sampling method did you use? How did you select these 25 students? It turns out that the process you use to select the sample is what makes a sample representative or not. And the goal when you select a sample is really to make it as representative of the population as possible, because the ultimate goal is to explain something that is happening in the population. So you want your sample to be representative of that population. So what makes a sample representative, right? Let's see. So a representative sample is the result of an unbiased selection of elements, right? And when you have an unbiased selection of elements, when you have a representative sample, then any differences between the sample and the population are there just by chance, not by some systematic process that that drove you to select some elements of the population over others. Right? So this will become more clear with a couple of examples in the following slides. So a representative sample is a sample that was obtained in an unbiased way, right? That means that there was no systematic way of including or excluding elements of the population while selecting the sample. Right. Notice here that what makes a representative sample is the process of collecting it in an unbiased way. It doesn't matter that the sample ends up looking a little different than the population. What matters is that the process was unbiased, right? That in the process you didn't exclude or include some elements over others. So let's understand this with a couple of examples. Right. Suppose though I have a population of CHHS students, right? And suppose we're 6 years ago, when the major was about 100 students in total. It's about 250 now, but there was a time when we had 100. And suppose that the population is, well, these 100 smiley faces, they're all happy. And there are 4 types of students, right? You have the orange students, the green, the blue, or the pink. Now, we want to select a sample of those, a sample of 10 students, 10 CHHS students. Now, suppose I select these 10. Right? And I select them because they are in my CHHS 385 class. Right? So I select them because they're in my class. Is that a representative sample? And the answer is no, because I selected them, right? Them being selected depended on this criteria of them being in my class. And by me doing that, by me selecting them based on that criteria, I systematically excluded all the rest of the students who are not in my class. So these students who were not in my class had not a chance, didn't have a chance to be in the sample, and therefore I excluded them systematically. Therefore, the sample is not representative. Now, it doesn't matter really that they are, the composition of the sample doesn't matter, right? It is not non-representative because the sample is different from the population. It is non-representative because the way I selected them. Now, let's suppose in order to select those 10, a sample of 10 CHHS students, I put some flyers on the wall and ask students to volunteer for a study. And 10 students show up and they are my sample. Now, is that a representative sample? And the answer is no. It has nothing to do with the composition of the sample, that it's different than the actual population composition. It is non-representative because they selected themselves, right? So they volunteered and selected themselves. Now, those who couldn't volunteer or didn't volunteer were excluded from the sample, and therefore had a zero probability of being in my sample because they didn't volunteer. So they were systematically excluded from the sample, and that made this sample non-representative. So on a third example, let's say I select the first 10 students that walk through the office door. Is that a representative sample? The answer is no. It is not representative. Why? Because I selected them based on them showing up early in the building or in my class, right? And that makes them sort of different than the other students who did not show up that day, let's say. So these guys who did not show up or showed up late were excluded. Right? They had a 0 probability of being in the sample, and that's what makes this sample a biased sample or a non-representative sample. So, in summary, when you select the elements of the sample based on some criteria, or when the elements select themselves based on some criteria, the sample is likely to be non-representative, because by you imposing this criteria, or by them imposing this criteria to be in the sample, that excludes the rest of the population, and that brings bias to the sampling process. So how do you get a representative sample? Right? If you cannot select them, or they cannot select themselves, how can we get a sample? Well, the only way to obtain a representative sample is when these elements are selected randomly. Right? You use a random process to select this. You have a list of all the population, and from that list you select your sample randomly. A computer selects them for you. It is not you selecting them based on some criteria. It is not them selecting themselves based on some criteria. It is a computer selecting them purely by chance. All the elements have some probability of being selected. You're not selecting some over others. So bias is eliminated when they don't select themselves or you don't select them. It is a computer selecting them. So let me give you an example from our population of 100 students. I asked the computer to pick 10 students randomly, and the computer does so. Is that a representative sample? Yes, it is. Yes, it is. But notice that this representative sample is actually a little different than the actual population, right? It's 40% orange, but the population is 65% orange. That doesn't matter. It is still representative because the elements were selected randomly. There was no bias introduced in the selection of this sample, and that's what makes it representative. So in summary, a sample is a subset from the population. We study samples because it is not feasible to study populations in most cases, nor we need to do that. The goal is to obtain a representative sample because we want it to reflect all the characteristics of the population. The only way to do this is to use probability theory. The only way to avoid introducing bias in the selection is to use probability theory, or that will help us select a sample randomly from the population. This is key. What makes a sample representative is not its composition, but the way it was collected, right? But sometimes we cannot obtain probability samples or random samples. So we use other techniques that we will discuss in other videos. In the next lectures, we will discuss how to obtain probability samples and non-probability samples. Make sure you have a firm understanding of what a representative sample is. We will be throwing the concept of a representative sample over and over during the course, so make sure you understand what that means, not only for this course, but to be an informed citizen and a good consumer of other research. Thank you for listening.